Yagi antenna. Yagi antenna. Yagi antenna is the most commonly used type of antenna for TV reception over the last few decades. It is most popular and easy to use type of antenna with better performance, which is famous for its high gain and directivity. The frequency range in which a Yagi antenna operation is around 30 MHz to 3 GHz, which belongs to the very high frequency and ultra high frequency bands. A Yagi antenna has three main elements that combinedly forms its structure. These three major elements are driven element, which is generally a half-wave folded dipole, a reflector, and directors. The structure contains one driven element and a reflector, which while directors can be more than one. Figure below represents the structure of Yagi antenna, where driven element is a folded dipole and which consists of insulator and two directors, and a reflector which reflects back from driven element to the directors. Construction of Yagi antenna. Basically, the arrangement is said to be an array of active and parasitic elements. The dipole generally a metallic rod acts as the active element as external feeding is provided to it using transmission line, while reflectors and directors are parasitic elements of the structure. The parasitic elements are also metallic rods placed parallelly in line of sight orientation with respect to the driven element. Parasitic elements, no external exhalation is provided to the parasitic elements. However, when the dipole is excited using a transmission line, then the current that flows through the driven element includes voltage in the parasitic elements. All these elements are mounted on the center rod that acts as horizontal support. The reflector is present at one of the ends of metallic rod and has length around 5% greater than the length of driven element, while the directors are almost 5% shorter than the driven element, i.e. lambda by 2, at the resonant frequency, and are placed at the other side of the dipole, as they are used to provide maximum directivity to the antenna. So far, three element aerial. The length of the elements can be considered as length of driven element is 475 by hertz megahertz feet. Length of reflector is 500 by frequency feet. Length of director is 455 by frequency feet. Working of Yagi antenna. We know that the external exhalation is directly provided to the active element of the arrangement, i.e. the dipole. The flow of current through the active element includes a voltage in the parasitic elements that cause current to flow through it. The element having a length greater than lambda by 2, i.e. the reflector, shows inductive characteristics. Therefore, the current is reflector lacks the induced voltage, whereas the one shorter than the half wave dipole, i.e. the director, is capacitive. So the current flowing through it leads the voltage. Yagi antenna arrangement. Working of Yagi antenna. As we know that director is placed in front of driven element, so these directors add the field of the driven element in the direction away from it. When multiple directors are placed in the arrangement, then each director will help provide excitation to the next one. Also, the reflector in the opposite direction as that of director, when accurately placed, adds the field in the direction towards the driven element. This is done in order to reduce the losses due to the back radiated wave as much as possible. In order to get the additional gain, multiple directors can be used in the direction of the beam. The spacing between the elements to form a Yagi structure is as follows. Spacing between the directors is 0.1 lambda to 0.3 lambda. Spacing between reflector and driven element is 0.23 lambda to 0.35 lambda. Spacing between the driven element and director is 0.125 lambda to 0.15 lambda. Initially, exciting the driven element is provided using fed lines. This causes the emission of radiation from reflectors towards the directors. Moreover, a portion of emitted radiation excites the parasitic elements that further re-radiate the radiation. The length of the element and spacing is of greater importance here because radiated element from each element gets summed in front direction and so cancels the back radiated wave. Characteristics of yagi antenna. A yagi antenna is said to be a beam antenna if it is only three elements array, i.e. driven element and reflector, and only a single director. It offers moderate unidirectional directivity. The gain offered by a yagi antenna is around 8 dB with front to back ratio of approximately 20 dB. In order to increase the directivity, more element can be added in the array. Another name to this antenna is super directive antenna due to its high directive gain. It is frequency sensitive, thus is a fixed frequency device. Thank you.